Let's talk about Euler paths and circuits. This is Leonhard Euler, brilliant mathematician, not a very good picture of him. But the question really is it possible to cross each bridge exactly once and finish where you began? And this was a really big question, actually, in this town right here, Königsberg, back in the 1700s. And instead of walking across the bridges, I'm going to drive my yellow Lamborghini, and I don't think this is going to work too well. And what we're trying to do is basically cross every bridge exactly once and finish where I began. So let's just randomly start here. I'm not going to give you the answer to this, actually. We're just going to experiment with it a little bit, and then we'll go from there. So we'll start here, and we're going to cross bridge 5, then 1, then 2, then 6, then 7, then 4. And okay, so here we have a problem based on what I just did. I went through here and here and here, and I never crossed bridge 3, and I can't end up back where I started based on what I just did. So maybe there's another way. Maybe we'll start in the middle. We'll put my yellow Lamborghini in the middle, and we'll go 3, 4, 2, 1. Okay, well, 3, 4, 2, 1 puts me back over here, and then to get back to hit these other bridges that I haven't hit yet, I would have to cross one of the bridges I've already crossed. So maybe I could start here. So we'll try that, and we'll go 7, 6, 5. Well, no. 7, 6, 3, 4, 2, 1. Nope. Okay. I will let you experiment with that one. But we're still going to take this idea and run with it. This actually was an idea that sparked a lot of what Euler eventually proved with this that we're going to determine as we continue through this lesson. So here goes. If possible, name a path in which you will cross each edge exactly once. So just to review, an edge connects the vertices. So this is a vertex, and edge would be like the lowercase letters in this case. So if possible, name a path in which you will cross each edge exactly once. And you can start anywhere you like, and maybe it will work and maybe it will not. So I'm just going to start and try, and I recommend that you do the same. So I'm going to start at 1 because I feel like it. So I'm going to go here, 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 here. Okay, so just to review, I have to cross every edge exactly once. So I just crossed A, B, C, H, G, F, and then I could hit E, and oh, I'm back here, but I haven't hit D yet. So, let's see. Let's do 2 to 3. So let's do this, 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 this. We can do that. And now they didn't tell me I have to start and end at the same place. So dun, 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 dun. And then I can hit D. There's one. There's a path right there. So let's do it. Let's actually, we're going to start at 2. I'm going to label it with a 2. But then I'm going to go to 3, then 5, then 6, then 4, then 5 again. It's okay to hit it more than once. Then 1, then 2, then 5. Now, I could use the lowercase letters if I wanted. I could say B, C, H, G, F, E, A, D. That works also. So either way is good. I'm going to use the vertices instead. All right, so here goes. If possible, name a path in which you cross each edge exactly once and return to the same vertex you started on. So now I need the beginning and the end to be the exact same. So like 2 and 2, or 5 and 5, or 1 and 1, or whatever. So I need to start and end on the same vertex. And let me just go ahead and jump straight to the practicality of this. Let's suppose you are delivering mail, right? And you have to go through all these roads. And the most practical thing for you to do is to park your mail car and finish where you started, so you will only walk each path one time, right? Well, if you noticed what I just did, I did that, and I started at 5, but I ended at 2. So I wonder if there's a way that we can start at 6 and end at 6 and cross every edge exactly once. And if you notice what I just did, I did cross every edge once except for D. All right, so maybe if I do this one, well, that's going to be pretty much the same thing, and I haven't gotten D yet. Or maybe I can go ahead and hit D, but I haven't gotten C and B. Maybe if I try 5, we could do dun, 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 dun. Oh, what about these up at the top? Dun, 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 dun. Still got to get this. So I'm going to go ahead and tell you this one is not possible. So not possible. So why don't we jump in with determining what an Euler path is and what an Euler circuit is. So here goes. An Euler path is a path. Well, that's self-explanatory. In which each edge is crossed exactly once. There we go. We're going to cross each edge exactly once. And that's just an Euler path. And that is what we did right here. But now we're going to get a little more technical. An Euler circuit. A circuit is when you begin and end in the same place. So we're going to start the definition the same. It's a path in which each edge is crossed exactly once. But again, a circuit has to begin and end in the same place. Like in electronics, if you have a circuit, then you are going to complete a path. Completing it means you start here, you end here. Or to use another example, there used to be people that would complete a circuit. Like, okay, like a century ago, in some of the more mountainous areas, there would be several churches, and they would have one preacher for several churches, and on Sundays he would complete his circuit. It was actually called that. And so what he would do is he would start in a place, and he would go to the different churches, and he'd go through this path, and then he would end up where he started, right? So it's that kind of thing. So a path in which each edge is crossed exactly once, and you or me begin and end on the same vertex. Okay, that is the big idea so far.